Let me start with a situation almost every welder has faced. You complete a weld. The bead looks smooth. No undercut. No visible porosity. Inspector signs it off. Next morning, crack. Right along the weld or heat affected zone. Now the big question, if the weld looked perfect yesterday, why did it crack today? Most welders blame electrodes. Some blame base metal. Some blame luck. But in many real cases, the actual reason is simple and ignored. No preheating. Today, I'll explain why preheating is required in welding, not from textbook theory, but from real workshop logic, the kind that saves rework, rejection, and reputation. So first, what exactly is preheating? Preheating in welding means raising the temperature of the base metal before welding and sometimes maintaining that temperature during welding. This heating is done around the weld joint, on both sides of the weld, to a specified minimum temperature. This is not for comfort, and it's not to make welding easier. Preheating is done to control what happens to the metal after welding. You'll commonly see preheating used in thick plates, high carbon steels, low alloy steels, cast iron, pressure vessels, structural joints under restraint. Metallurgical reasons for preheating. Now let's talk metallurgy, but don't worry, I'll keep it simple and practical. Hydrogen-induced cracking. This is the number one reason preheating exists. Hydrogen enters the weld from moist electrodes, flux surface moisture, oil, grease, paint. When welding happens, hydrogen dissolves into molten weld metal. That part is unavoidable. The problem starts after welding. If the weld cools too fast, hydrogen gets trapped inside hard microstructures and creates pressure. That pressure leads to delayed cracking, sometimes hours or even days later. Preheating helps by allowing hydrogen to escape slowly, reducing hydrogen concentration in the weld and has effect of rapid cooling. Imagine pouring hot glass into cold water. What happens? It cracks. Steel behaves in a similar way. When cold base metal absorbs heat rapidly from the weld, cooling rate becomes very high. The has transforms into hard and brittle structures. This is where martensite comes in. Martensite is not a defect. It's a very hard but brittle structure. High hardness means high strength, low toughness, high cracking tendency. Martensite forms when carbon is present. Cooling rate is fast. Preheating slows down cooling, giving steel time to form softer, tougher microstructures instead. Now let's talk about stresses. During welding, weld metal is very hot. Base metal away from the weld is cold. This temperature difference causes uneven expansion and contraction. As the weld cools, weld metal tries to shrink. Base metal resists this shrinkage. That resistance creates residual stress. If the material is hard and brittle, cracks form easily. Preheating reduces temperature gradients, cooling speed, internal stress buildup. Materials that require preheating. Carbon steel. Low carbon steels generally do not require preheating under normal conditions. However, this statement is true only when certain conditions are satisfied. Preheating may still be required if the material thickness is high, the ambient temperature is low, hydrogen control is critical, the joint is highly restrained. So remember this clearly, it's not just the material, the welding conditions decide. High carbon steel almost always requires preheating. Why? Higher carbon means higher hardenability. Higher hardenability means higher hardness in the has. Higher hardness means higher cracking risk. This is not optional and not debatable. Preheating is mandatory in most practical cases. Low alloy steels containing alloying elements such as chromium, molybdenum, nickel. These elements increase hardenability, even if carbon content is moderate. As a result, cooling becomes more critical. Has hardness increases, hydrogen cracking risk rises. That's why even medium thickness low alloy steels often require preheating. Cast iron is a special case. It is very brittle, high in carbon, extremely low in ductility. Without preheating, cast iron will crack during or after welding. This is not may crack. This is will crack. That's why cast iron welding always requires proper preheating. Controlled cooling, sometimes post-heat as well. What happens if preheating is ignored? Let's be very clear here. Ignoring preheating can lead to cold cracking after welding, cracks in weld metal, cracks in has repair welding, rejection by inspector, loss of customer trust. I've seen pressure vessel shells cracked overnight. I've seen crane components fail load tests. And in many cases, the root cause was no preheat. Now the million-rupee question. How to decide preheat temperature? Factors which influence preheat temperature are carbon equivalent thickness of material, ambient temperature, welding process used. Carbon equivalent, CE, carbon equivalent combines carbon manganese alloying elements. Higher CE means higher hardenability, higher preheat requirement. Engineers use CE to estimate cracking risk. Thickness of material, thicker material removes heat faster, needs higher preheat. Thin plate may need zero preheat. Thick plate may need 150 to 300 degrees Celsius. Ambient temperature, welding in winter mornings or cold shops. Preheat requirement increases. Cold steel behaves like a heat sink. Welding process use processes with higher hydrogen input, lower heat input, need more preheat than controlled processes. Next we will discuss methods of preheating. Common methods of preheating are gas torch, electrical resistance heaters, induction heating. Gas torch most common in workshops. Good for small jobs. Localized heating. Problem: uneven heating if done carelessly. Electrical resistance heaters used in pressure vessels. Pipelines, critical joints. Very uniform and controllable. Induction heating fast and precise. Used in high-end fabrication. Common mistakes during preheating: heating only one side. Heating too small an area. Not measuring temperature. Stopping preheat midway. Preheating must be uniform and verified. Codes or standards reference: preheating is not optional when specified by codes. Standards like ASME, AWS, and ISO clearly define when preheating is mandatory. You don't need to memorize tables, but you must respect WPS requirements. Practical tips for welders. Always check temperature using temp sticks. Infrared thermometer. Heat evenly on both sides of the joint. Maintain interpass temperature. Do not rush cooling with water or air blowers. Preheating is not fire, it's controlled warmth. So let's wrap this up. Preheating prevents cracking, controls hydrogen, reduces stress, increases weld life. Yes, it costs time. Yes, it costs fuel or electricity. But repairs cost more. Remember this line: preheat doesn't improve weld looks, it improves weld life. If this video helped you understand preheating clearly, like the video. Share it with your welding group. Subscribe for real-world welding knowledge. And comment below. What welding problem are you facing on site right now? I'll see you in the next technical breakdown.